Hello, my name is Yaroslav Borets, and I'm a product manager here at SaaS Labs that's working with a team that's delivering SaaS performance to our customers. Today, I would like to give you a quick TED talk into what SaaS performance is, how to use it, as well as provide some quick tips on how to take advantage of all the features and functionality. Before I dive into the product, I really wanted to talk about some of the current performance testing challenges that our customers have reported to us in the past. Number one, front-end application performance is rarely tested and verified ahead of production releases. In many cases, organizations are finding performance issues either when they hit production using their RUM products or when customers actually report issues via support channels. Second, measuring performance of a single-page application is a challenge and users not sure where to start. Specifically, ever since organizations are starting to adopt Angular and React and Vue.js, teams are quickly realizing that the old way of measuring performance for their application around page load times no longer applies in the world of single-page apps. Number three, finding the root cause behind the discovered performance issue can be quite difficult, and it has to do with so many amount of factors that impact application performance, from networking to JavaScript to CPU to other third-party libraries that are being loaded into the view at the same time. And any of these factors can impact performance, and it's important for organizations to have necessary tools to determine where the problem is coming from. So what exactly is SaaS performance? In essence, it's a tool that enables customers to track front-end application performance over time and capture new regressions as part of continuous integration, continuous delivery system. Our main goal is to build a product that you can easily embed into your existing continuous testing pipeline and capture more additional application performance metrics and assert against them in the way that you see fit. What sets us apart compared to other tools in the performance testing space is that our main focus is not on putting load or stress in the staging or pre-production environments, nor is it doing production monitoring. Our main objective is on helping you and your team to discover front-end performance regressions as part of the generic continuous integration process and help your team be aware of front-end performance issues as soon as they occur and as soon as they're introduced into the dev branch or staging branch. Of course, you can run performance tests at any point, but the value really lies in the ability to discover front-end performance problems that as soon as they occur and as soon as they're introduced in the code itself. So what are the main features? Number one, we provide customers with the CLI tool as well as full framework integrations to allow anyone to run one-off performance test for URL of their choosing, or repurpose their existing WebDriver tests and capture performance as part of them as well. Number two, obviously, whenever you run tests on SaaS Labs with performance enabled, we capture a lot of performance metrics and their histories, specifically performance scores, time to first meaningful paint, time to first interactive, speed index, and many more, and I'll cover that in details in a bit as well. Number three, we establish baselines for all the metrics that we capture. And baselines are actually quite useful when it comes to discovering performance regressions later on. If we notice that existing baselines are exceeded for a specific set of metrics that you're looking to validate or verify, we will let you know when the baselines are continuously exceeded and we detect a new change point. Number three, if there is a problem that has been discovered, we give you a lot of logs and a lot of the information in order to debug and pinpoint the root cause of the performance problem. And I'll show that in a bit as well. So how does it actually work? So whenever you execute tests on SaaS Labs and enable performance for that test, we actually look at each individual page load event that occurs during the test execution process and start capturing tracing information and process that tracing data and turn that into metrics. So in the example here, my test navigates to the main homepage of saaslabs.com, finds the login page and clicks login. That generates two individual page load events. One is to the main homepage and second one to the login screen. And it would capture performance values and performance scores for each individual URL navigation that occurs during the test execution. So what do we actually capture whenever SaaS performance is enabled? The top level section focuses on performance scores, page load times, time to interactive, speed index, and estimated input latency. The bottom section actually focuses on a lot more UX specific metrics. So that includes time to first byte, first paint, first contentful paint, first meaningful paint, time to interactive, and first CPU idle. All these metrics are also aligned with the film strip as well. So you can see at which point in the page loading process individual metrics were fired and how the application looked like at that point as well. So why are these metrics important? Why are we capturing things that we believe are important to our customers? The Google team has a rubric that defines all of the UX metrics and all the performance metrics into three categories. Number one, is it happening? Number two, is it useful? And number three, is it delightful? And depending on which experience you're trying to optimize, specific metrics can help you do that better. So obviously, the most important thing that you can give your customers is delightful experience. And delightful experience, it can be measured by two things. Number one, it's speed index and time to interactive. We advise our customers to look into time to interactive first as a first source of truth when it comes to what the true user experience is and how their customers are perceiving the application when they're loading the page. Additionally, if you're trying to optimize the loading process as well, or just help customers present something to the users as soon as the page starts loading, optimizing for time to first paint and time to first meaningful paint. So then the intention here, we don't want just to give customers a single metric that they should be focusing on. We want to give them a whole breadth of events that they can optimize for and really improve the overall user experience of their application. So how do you actually run your first performance test? There are two options. Option one, simply use our Speedo CLI tool. You can quickly run performance tests against any public URL using Speedo. First, install Speedo in your local environment, and then call Speedo run with the URL you're choosing to start running tests on SaaS and capturing performance values as part of it as well. Interesting fact about Speedo, Speedo actually validates incoming data against the previous baseline information, and if baselines are exceeded, Speedo will fail the test. Option two is to repurpose an existing test, add a few additional desired capabilities to the test, such as extended debugging true and capture performance true, and your tests will be capturing performance information as well that you can later use for your purposes. Or you can also search for performance validations as part of that test as well. One caveat, running performance tests will take longer to execute than equivalent functional tests, so don't just blindly add capture performance to all of your tests. Be mindful and thoughtful where you do this. And the reason why is the system needs time in order to make sure that the page finished loading and all the long tasks have been loaded, as well as all this, the CPU is finally idle. Now, let me quickly demo how this all works. Let's do a quick demo. So as I mentioned, it's very easy to start capturing performance values for your existing WebDriver tests. So in this case, I have a very simple two-step functional test that simply goes to saucelabs.com and opens the sign in button and clicks it. The expected behavior is the page first would load saucelabs.com, but then after clicking the sign in button, a new URL would be presented. And our system will not only capture the performance values for the first one, but also will capture performance values for the second URL navigation. In order to enable performance for your tests, simply pass in two new desired capabilities. One is extended debugging true. The the other ones capture performance true. Now that everything is added and set up, we can simply run these tests on SaaS, and I will walk you through exactly where the performance value and performance information lives within our UI in a second. Now that tests are complete, let's navigate to one of the tests. The performance values for all the information that has been captured as part of the run is stored under the performance tab, and you can see that there are two dedicated URLs that had their performance values captured. Simply clicking on the link on the arrow left and right, you can cycle through all the URLs. By default, we present customers performance score, page load time, time to interactive, speed index, and their historical values over time. Users who really want to see more value are more than welcome on clicking on the full performance report and seeing all the metrics that we currently capture. In this case, we expand the view beyond just the top 4 and present time to estimated input latency, first CPU idle, time to interactive, time to first byte, time to first paint, and so on. As well as you have access to the entire trace log, where you can actually see how the application performed, how the application loaded from a very granular, low-level perspective. As I mentioned, there's also Speedo as a way to run performance tests, but I will talk about it in the next section when we start talking about the regressions. Now that the first demo is done, let me quickly walk you through some of the quick testing tips that you can use up until this point. So in theory, functional and performance testing should be approached differently and not mixed together. That's very important for everyone to realize and understand. Additionally, performance issues become way more obvious when they're executed against throttle environments. There are ways to run tests on SaaS under throttled conditions, and if you're very serious about performance, you would probably default your performance tests against some sort of throttled environment. So this way, if there is a performance problem, it's definitely going to be magnified and captured as part of the regression detection algorithm. And lastly, it's very important to focus on metrics that truly define your user experience. As I mentioned, just looking at page load time might not be enough. Focusing on time to interactive, time to first meaningful paint, and maybe even performance score could be a great place to start to make sure that your users are getting consistently great experience with each release. So what about performance regressions and how do they work? So as I mentioned, whenever tests are executed on SaaS Labs with performance enabled, we establish performance baselines for all of the metrics that we capture based on historical values. The goal behind baselines is to help customers understand what is the predictive range for their performance data and give them a way to validate for performance regressions without really setting absolute performance budgets. And since we're using fairly complex algorithms, we're not only making sure that outliers are ignored, but also expected ranges are pretty flexible and they're ever changing. And this way, we're able to detect true performance regressions and not just one-off flaky behaviors. In the UI, baselines are displayed in a yellow color, and by hovering over, you can clearly see them displayed directly in the performance tab as well as in the performance report. And if there is a performance regression detected, baselines will disappear and you'll have an option to accept the regression. And I'll demo that in a second as well. Now let's do a quick demo. Now, when it comes to the demo, I would like to demo the regression detection algorithm against our own React app that we have built specifically for these purposes. The app is built on top of a platform that allows us to quickly modify the actual app code and see how it changes the application performance. So if we were to call a speed run command against this URL, it would spin up a series of jobs to establish performance baselines first. At the same time, we're also passing in a few additional parameters to make sure that the test executes with all the throttling disabled against macOS platform and browser version 74. Now, once the test completes, we should see a quick report that describes the metrics that have been collected as part of the latest run. Now that the test is completed, you can see Spiro summarized a lot of the performance values that have been captured. And after running 10 tests to establish performance baseline, it ran one more test to get, and that test is used to generate this table here. But in general, since the last values were within the expected performance range, the test passed. By default, Spiro validates against the performance score, which is this. So, but you can specify any of the metrics that are listed here. Now, if we were to look at the UI, we would see that the UI is pretty standard, has a pretty high score, and all the metrics that you would expect to see are also displayed here as well. Now, let's introduce a performance regression into this application. So we have a function called mine Bitcoin that we can call, and as a result, this function will introduce an artificial 10-second delay towards the page load event. So as you can see, the page is reloading, but it takes quite a long time before even a single element on the page is loaded or painted. From the functional perspective, the app still works fine, but from the performance perspective, the user experience is significantly impacted. Now, let's run Spiro again with exactly the same parameters against this test and see what we get. Is complete. We can clearly see that that there is a problem in the page, and we can quickly investigate the problem by navigating to the link itself. By looking at the performance report right now, we can clearly see that the performance score has significantly gone down, and page load time, time to interactive, and speed index have gone up. Additionally, we can see that out of all the metrics that we have, one of the metrics has not been impacted. Specifically, time to first byte remained the same, while time to first paint has significantly increased as well. Additionally, you can see that the JavaScript script evaluation event is now contributing towards 10 seconds of the overall page load time. So in general, just by looking at the metrics, the problem is probably lies on the front end, just by looking at the data itself. So if we were to pull up a trace log of the entire page load event, we can the evidence there actually backs up our initial theories, and we can actually see that there's dedicated app mount and React events that are really blocking the entire page from being loaded. Now, not in many cases, not every performance issue is as drastic and as important. With that in mind, we allow our customers to actually reset the baseline. By clicking this button, customers can reset the baseline and go back to running tests again. And as a result, they're able to unblock their pipeline and continue their release the product, but take note of the issues and the regressions that they have discovered. Let's go back to the tips. So there are a few tips when it comes to debugging performance issues in general. It's very important to understand which metrics are impacted alongside the ones you're verifying. In many cases, you only care about one or two metrics, but other metrics that are related to that individual event might tell you a better story. So for example, correlation between some of the events can point towards a JavaScript problem or networking problem. So if time to first byte is going up, that's probably pointing towards a networking problem. However, if time to interactive is increasing but everything else is staying the same, that means it's a JavaScript problem. Additionally, using Chrome DevTools Viewer is an ultimate source of truth and is really, really useful when it comes to really deep diving into the performance of the page and giving you visibility into what is actually blocking the requests and blocking the rendering of the application. And lastly, knowing the history of your individual metrics is quite useful, and seeing how they correlate with each other can really tell you a better story about how the application itself is evolving and what's pushing the time to interactive or page load times in general. So how do you take advantage of all these features and functionality in the context of continuous integration systems? Our vision behind SaaS performance is that it should be used to enable you additional performance testing step in your continuous integration system. The objective is to create additional performance testing line in your delivery pipeline that goes after functional tests and is used to verify the performance of your core flows as well as your main application. So how do you integrate SaaS into some of the CI tools that you have today? So there are two ways. Obviously, you can use our CLI product if you have a fairly simple application or you just care about top level URLs, or you can combine WebDriver tests as well as use Spiro as well, Spiro Analyze command specifically, to evaluate the performance of given flows and of given WebDriver tests. The idea, the way this works, is you would run a dedicated performance test. The idea is you would run a test that captures performance first, and then you would call afterwards, once the test, you would call a Spiro Analyze command and pass in the test name to see if there have been any performance regressions for the specific test. Now let's do a demo. So I've set up a custom Jenkins pipeline that essentially creates a dedicated performance tab right before releasing the code. So it has a place where tests are being executed, end-to-end tests or functional tests, and then it has a performance validation as well. The product is relying on our Docker container of Speedo. So first I'm uploading the Docker into the system, and then I'm using Docker as a Dockerized version of Speedo to first run the Speedo run just to get the values into just to show you that it's possible. But at the same time, I'm also using analyze command that relies on the job that was executed earlier. So it outputs me with all the URLs that have been visited as part of that test, as well as tells me if there is any regressions against the metrics that I have been trying to verify. If there is a problem, I simply can go back and validate the regressions. But in general, the integration with CI is fairly simple. You just need to follow typical standards as well as a very generic pipeline script. By using Dockerized version of our Speedo tool, you can quickly embed it into your CI system. Additionally, you can run, if there's any problem discovered, since it's a dedicated CI step, you can quickly see and validate the problem. And you can use Speedo Analyze as a way to validate the regressions against the previously executed web tests, and with a nice output and a nice chart that's embedded directly in your CI tool. And all of your engineers and any person who is using the CI product today has access to all the performance data and performance values. Now, to summarize, a few more tips. Number one, treat performance end-to-end or functional tests as separate parts of your pipeline. Don't try to mix performance and functional tests into the same suite. Treat them separately. That's better for visibility, better for debugging, as well as performance tests can be slower than your typical functional tests. So you want to also don't necessarily overwhelm your release pipeline with things that nobody's looking into. Tip number two, if you're reusing existing functional tests, try to rerun them again as part of the performance step so that you can get fresh values, and then values that are captured again are totally undependent or unbiased by the work that has happened as part of the functional tests. A good example is many customers run functional tests under higher parallelization. As a result, they might be unofficially putting stress on the API services of their staging environments, and as a result, seeing artificially lower performance numbers. Number three, in order to minimize dependencies as part of your build process, use the Docker image of our Speedo Analyze command and really try to use a single tool in order to get all the value and validate for performance regressions as part of your continuous integration system without having to worry about performance budgets or anything else. If you have any questions, feel free to reach out to me directly at yaroslav@saaslabs.com, or you can also find us by reaching out to our support team at help@saaslabs.com.